Okay, so you better pause this video because right here is the spreadsheet template for the nonlinearity of copper. So there's not really any kind of calculations that we want you to do with this lab, but we just really want you to plot some data and interpret what the data is trying to tell you. So up here at the top you will see a graph that represents the buck instrument, and then you will see a graph down here below that represents the variant instrument. So what we need you to do is we need you to take a look at your copper standards, and we need you to plot them just like a regression line, but you do that using the scatter plot feature. So again, I'll put my concentrations in the first column, and I put my absorbance reads in the second column. And when I do that, I will highlight those two columns. I will go up into the top and hit insert, and then I will hit scatter plot and choose the one that's only for the dots itself. Do not connect them with a line. That's not the purpose of plotting the data. We just want you to plot the data. So I'll do that with the secondary wavelength data, and I do that with the third or tertiary wavelength data. And I plot all three of these on the same graph. And that's what you're seeing here. And I've labeled them just so you know which one is which. So my primary is the blue one, my secondary is the red one, and my tertiary is the green one. And automatically, when you plot it, you can already see what's going to happen here. Because my primary stops at 5. After 5, my linearity begins to go off. And if I look at this curve, I'm seeing some curvature. The higher that I go, the more curvy it gets. Well, the secondary probably has a higher linear range. So that line should probably be a little bit straighter. And there you go. It looks a little straighter to me. And then finally, the tertiary has even higher linear range. So that means that this line will be even more linear. And out of the three, that one is the most linear. But look at your absorbance readings. Your absorbance readings get cut each time you go from primary, secondary to tertiary. So if I take a look at this first one, on the primary it read 0.04. On the secondary, it got cut in half almost to 0.02. And then on the tertiary, it got almost cut in half again to 0.01. So these are the trends that you want to start looking for and that you want to start picking up on, because this is really what should be happening, or maybe something close to it. Now you're seeing an area on my spreadsheet that you will not have, and that is the percent of the primary and percent of the secondary. You will not see that. That is just really for me, and that's for me to take a look at your data to make sure that you're providing reliable data that you have not made up or that's not out of whack some form or some fashion. So does this person really have good data or not? I'm not going to tell you that because I don't want you to finagle your data to make sure that it will work. But that's what you need to do for the first half of the AA spreadsheet. The second half of the AA spreadsheet is something identical. And this is the variant instrument, known as the adjuvant instrument now. So primary, secondary, tertiary, just as before. You plot the absorbance reads just as before. Now I want you to take a look at this person's data. These are different instruments. However, the different instruments are running the same sample. And with this one I get a 0.1 for part per million 1. And this one I get a 0.043. So there's an issue here. I'll go ahead and warn you, there is an issue where this same sample is not reading the same on both instruments. This should not be happening, right? I should really see an absorbance value that are closer together, even though they're ran at different instrumentations, maybe with different lamps. Well, it's still absorbing at the same lambda, so I should still see some same absorbance as far as magnitude goes when it concerns running these standards that have been pre-made. So here we go, 0.1. Well, I ran it on the secondary, got 0.05, half, and I ran it on the tertiary, and I got about 0.01, but that's way more than half. So is there an issue here? I'm not telling you. And then we've plotted that info over here to the side. And I see the blue is my primary. I see way more curvature in this one. I see my secondary straightens up a little bit. And then finally my tertiary that's down here at the bottom. So that's all that you've got to do for the varying copper wavelength lab. No calculations really at all. You just want to plot your data, take a look and compare the data, figure out what we're trying to get across to you in the lab, and then make those conclusions in the very end. So this is what the spreadsheet should look like. No calculations involved, no concentration work, no calibration curves, period. Nothing. It's just data and graph it. So here's your early Christmas present. See, aren't I a nice person?